Faster than a rifle bullet, the SR-71 Blackbird didn't just fly, it pierced the atmosphere at 3,500 feet per second. At Mach 3.2, the air ahead isn't a medium, it is a thermal wall, heating the cockpit glass to 600 degrees Fahrenheit. This was not a plane. It was a controlled explosion, riding the very edge of catastrophic engine failure known as an unstart. If the inlet spikes misaligned by millimeters, the shockwave would be violently expelled, slamming the pilot's helmet against the canopy. It held every major speed and altitude record, cruising in the top 1% of the atmosphere, where the sky turns a permanent, bruised indigo. From 85,000 feet, its sensors could photograph a license plate while scanning 100,000 square miles of enemy terrain per hour. You were the tip of a 107-foot titanium spear, penetrating sovereign airspace with total impunity. No stealth fighter has ever matched its kinetic dominance. If a missile launched, the protocol was simple: accelerate. But before the Blackbird could reign, the United States had to suffer a humiliating technological defeat. The story begins not with triumph, but with the terrifying vulnerability of the early Cold War. By 1954, the world had fractured into two nuclear-armed monoliths, the NATO alliance and the Soviet bloc. Information was the only currency that mattered. Washington was blind to the Soviet nuclear stockpile behind the Iron Curtain. President Eisenhower demanded eyes inside the Soviet Union, leading to the creation of the U-2 Dragon Lady. The U-2 was a delicate glider, designed to loiter at 70,000 feet, believing altitude was the ultimate shield. It was a fatal miscalculation. Soviet radar technology was advancing faster than American aerodynamics. The CIA's assumption of invisibility was shattered on the 1st of May 1960 over Sverdlovsk. An SA-2 guideline missile, guided by Fansong radar, detonated near Francis Gary Powers' U-2. The fragile airframe disintegrated, and Powers was captured, paraded by Khrushchev as proof of American aggression. The U-2 incident proved that altitude without speed was a death sentence in modern warfare. The CIA needed a new platform, one that didn't just hide from missiles, but could outrun the blast radius itself. The assignment fell to Lockheed's Advanced Development Projects, a secretive unit in Burbank known as the Skunk Works. Led by the acerbic genius Kelly Johnson, this was an engineering cult operating outside standard military bureaucracy. Johnson enforced his famous 14 rules of management, cutting red tape with a ruthless, dictatorial efficiency. Rule 3 was absolute. The number of people having any connection with the project must be restricted in an almost vicious manner. Engineers worked feet away from the shop floor, solving metallurgical crises in real time with the machinists. They were tasked with the impossible, an aircraft that could sustain Mach 3 for hours, not just seconds. The friction of air at that speed creates temperatures that melt standard aluminum frames into useless slag. The only metal capable of surviving the thermal stress was titanium, specifically the beta 120 VCA alloy. But in a twist of geopolitical irony, the world's primary supplier of rutile ore was the Soviet Union itself. The CIA set up a network of shell companies to covertly purchase the very metal needed to spy on Moscow. Every SR-71 built was forged from Soviet Earth, a secret metallurgical theft that went unnoticed by the KGB. Working with titanium was a nightmare. It was brittle, expensive, and reacted violently to standard workshop tools. Cadmium-plated wrenches caused corrosion, forcing Lockheed to design an entire new suite of tools from scratch. Even the water used to wash the panels had to be distilled. Tap water chlorine caused microscopic stress fractures. Johnson's team was inventing materials science on the fly, rejecting 80% of the initial titanium delivery. Beyond the metal, the shape of the aircraft had to defy the laws of radar detection. The SR-71 was the first aircraft designed with low observable stealth principles from the blueprint up. Its flattened fuselage and inward-canted vertical stabilizers were designed to deflect radar waves away from the source. The sharp chines running along the nose acted as aerodynamic stabilizers and radar scatterers simultaneously. To absorb the remaining energy, the leading edges were filled with a composite honeycomb structure, a precursor to modern stealth. The result was a radar cross-section 100 times smaller than an F-14, despite the Blackbird being twice the size. On the 22nd of December 1964, the first flight-ready operational Blackbird rolled onto the tarmac at Palmdale. Painted in a radar-absorbent black ferrite ball paint, it looked like an artifact from a future century. Test pilot Robert Gilliland strapped into the cockpit, facing a dashboard of analog gauges and 383 unresolved system errors. The J-58 engines roared to life, ignited by a shot of triethylborane, TEB, that burned a distinctive green flame. As Gilliland pushed the throttles, he wasn't just taking off. He was initiating a controlled thermal reaction. The aircraft leaked fuel on the runway because the tanks were designed to seal only when heat expanded at Mach speed. This was the wet wing design, a necessary compromise for a machine that grew several inches in flight. The first flight was a success, but the real test would be the physics of sustained supersonic cruise. Kelly Johnson had built his masterpiece, but the laws of thermodynamics were waiting to tear it apart. The central problem was friction. At 2,000 miles per hour, the Blackbird was essentially flying inside an oven. If the airframe were rigid, the thermal expansion would have ripped the rivets out and buckled the wings. Johnson's solution was counterintuitive. He built the aircraft loose, designing it to tighten only when hot. Corrugated grooves were machined into the wing skins, acting like metal accordions that expanded during flight. On the ground, the Blackbird rattled when you touched it. At Mach 3, it was a solid, stressed kinetic weapon. The landing gear tires, retracted into the fuselage, were subjected to temperatures that would melt rubber. Lockheed developed custom tires infused with aluminum powder, giving them a silver, metallic sheen to reflect the heat. Inside the cockpit, the pilot looked through quartz glass windows fused ultrasonically to the titanium frame. No glue existed that could hold the windows in place at 600 degrees, so they were literally welded to the ship. But the greatest challenge was the fuel. Standard JP-4 aviation kerosene would boil off and explode in the tanks. The Skunk Works needed a liquid that was stable enough to act as a coolant before it was burned as a propellant. They worked with shell oil to create JP-7, a low-volatility fuel with a flash point so high you could drop a match in it. In fact, if you tossed a lit cigarette into a bucket of JP-7, the fuel would simply extinguish the tobacco. This created a new problem. The fuel was so stable that the engines couldn't ignite it with a standard spark plug. The solution was triethylborane, or TEB, a pyrophoric chemical that explodes instantly upon contact with air. Every time the pilot moved the throttle to afterburner, a mechanical shot of TEB was injected to hammer the engine awake. The Blackbird carried only 16 shots of TEB. Once they were gone, the afterburners were dead weight. The engines themselves, the massive Pratt & Whitney J58S, were technological hybrids. Below Mach 2, they operated like standard turbojets, compressing air with rotating blades. Above Mach 2, the engine underwent a metamorphosis, bypassing the compressor to function as a ramjet. This transition was controlled by the inlet spikes, massive cones that moved forward and backward up to 26 inches. These spikes managed the supersonic shockwave, positioning it perfectly inside the engine throat to slow the air down. The J-58 was the only engine in history that became more fuel efficient the faster it flew. But piloting this machine required more than just skill. It required a physiological transformation. At 80,000 feet, the atmospheric pressure is so low that human blood boils at body temperature. A sudden depressurization would not just kill the pilot, it would cause their tissues to expand and rupture instantly. Standard flight suits were useless. The crews needed full-pressure suits identical to those used by NASA astronauts. The David Clark S-1030 suit was a self-contained environment, costing $120,000 per unit in 1960s money. Getting dressed was a 2-hour ritual involving multiple technicians, oxygen purges, and seal checks. Once sealed in, the pilot was isolated from the world, breathing 100% pure oxygen to prevent the bends. The psychological toll was immense. Crews sat in a cramped cockpit for 10 hours, fed through a tube in the helmet. They were the Haboose, a nickname taken from a venomous pit viper found in Okinawa, signifying their elite status. Selection for the program was ruthless, requiring top-tier piloting metrics and an astronaut-grade physical. Candidates were subjected to centrifuge tests, crushing G-forces, and psychological endurance evaluations. They had to demonstrate the ability to multitask while their brain was being starved of oxygen in altitude chambers. In the simulator, instructors would throw triple failures at them, forcing decisions in split seconds. "You don't fly the SR-71, one pilot said. You manage a crisis that hasn't happened yet." The training culminated in the first flight, a sensory overload of acceleration and vertical climb. Lifting off at 210 knots, the pilot had to retract the gear immediately before the speed limit tore the doors off. By the time the nose cleared the runway, the aircraft was already hunting for the stratosphere. Operational sorties began in 1968, flying out of Kadena Air Base in Japan to monitor Vietnam. The Vietnam War was a chaos of jungle canopy and guerrilla tactics, hard to track from the ground. The SR-71 provided the God's eye view, utilizing side-looking airborne radar to pierce the cloud cover. It could map the Ho Chi Minh Trail in a single pass, identifying truck convoys by their radar shadows. But the North Vietnamese were not helpless. They were armed with Soviet SA-2 missiles. The electronic warfare officer in the back seat, the RSO, watched the defensive systems like a hawk. A launch warning wasn't a possibility. Over Hanoi, it was a guarantee. The pilot would see the missile contrail rising from the jungle floor, a white finger of death pointing at them. In any other aircraft, you evade. In the SR-71, you simply push the throttle and watch the missile fall behind. The Blackbird was untouchable, a ghost that appeared on radar only long enough to prove it couldn't be caught. But the true test of the Blackbird wasn't over the jungles of Vietnam. It was in the deserts of the Middle East. In October 1973, Egypt and Syria launched a surprise attack on Israel, initiating the Yom Kippur War. Israel was reeling. Its tank divisions were decimated, and Prime Minister Golda Meir was considering the nuclear option. The Soviet Union began shipping nuclear warheads to Alexandria, threatening to turn a regional conflict into World War III. Washington was blind, satellite intelligence was too slow, and the battlefield was shifting by the hour. The SR-71 was ordered to execute Operation Giant Reach, a marathon mission from upstate New York to Cairo and back. This was a logistical nightmare, a 12,000-mile round trip requiring multiple mid-air refuelings over the Atlantic. Flying out of Griffiths Air Force Base, the crews had to hit tanker rendezvous points with second-perfect timing. If they missed a tanker by 1 minute, they would flame out and crash into the ocean. As they approached the Mediterranean, the Blackbird accelerated to Mach 3.2, entering the most heavily defended airspace on Earth. Egypt had a dense forest of SAM sites. But the real threat was the new Soviet-supplied SA-6 Gainful. Unlike the SA-2, the SA-6 was mobile, low altitude, and had a radar frequency the US had never jammed before. The pilot, Jim Shelton, pushed the aircraft to 80,000 feet, his RSO scanning the electronic spectrum for threats. "We were flying so fast," Shelton recalled, "that we were outrunning the sun." They crossed the Sinai Peninsula in minutes, their cameras devouring the entire battlefield in high-resolution strips. Below them, Israeli F-4 Phantoms were dogfighting MiGs, but to the SR-71, the war looked like static toys. Suddenly, the RSO's panel lit up. The Egyptians had fired a salvo of missiles. Shelton saw the launch flashes, but the geometry of the intercept was impossible for the missiles to close. The Blackbird was simply too high and too fast. The warheads detonated miles behind them in the stratosphere. But the danger wasn't just from the enemy, it was from their allies. As they turned back over Israel, the nervous Israeli Air Defense Force mistook the SR-71 for a Soviet MiG-25. Israeli F-4S scrambled to intercept, firing air-to-air missiles at the dark streak in the sky. The Blackbird outran those too, proving it was immune to both Soviet and American weaponry. The intelligence they brought back was decisive. It showed the exact location of the Egyptian armored reserves. Armed with this data, Israel launched a counteroffensive, crossing the Suez Canal and encircling the Egyptian Third Army. The photos were so clear, they could count the number of road wheels on the T-62 tanks. Diplomacy followed the data. The US brokered a ceasefire, pulling the world back from the nuclear brink. The SR-71 had proven it was more than a spy plane. It was a strategic asset capable of altering history. Speed was its weapon, but endurance was its Achilles heel. A standard mission was 3 hours. Giant Reach was 10 hours of grueling, cramped confinement. Pilots had to urinate into specialized bags while strapped into a pressure suit, a maneuver as difficult as the flying itself. The physical exhaustion was total. Losing 5 pounds of water weight per flight was standard. Yet, the aircraft demanded more. In 1974, it set the record from London to Los Angeles, 3 hours and 47 minutes. It flew faster than the rotation of the Earth, meaning the crew landed in LA before they had taken off in London. They had literally bought time, arriving in California with the sun higher in the sky than when they left. But in the 1980s, a new adversary emerged, one erratic enough to test the Blackbird's luck: Muammar Gaddafi. Libya had declared the line of death across the Gulf of Sidra, claiming international waters as sovereign territory. Gaddafi was sponsoring terrorism across Europe, culminating in the 1986 Berlin disco bombing. President Reagan ordered Operation El Dorado Canyon, a punitive airstrike against Tripoli and Benghazi. The SR-71s were tasked with BDA bomb damage assessment, flying in immediately after the F-111S struck. The element of surprise was gone. The Libyan air defense network was fully alert and looking for revenge. Pilot Brian Schul and RSO Walter Watson roared toward the Libyan coast at 2,100 miles per hour. They weren't just flying over a target, they were flying into a hornet's nest of angry SAM operators. Watson picked up the launch signals. Libya fired surface-to-air missiles, specifically targeting the Blackbird. Schul did something no pilot is trained to do. He pushed the throttles past the red line. The airspeed indicator wound past Mach 3.2, then Mach 3.3, entering a realm of thermal danger never tested. The aircraft groaned. The temperature limits were exceeded, but the speed kept climbing. They outran the missiles, turning the Blackbird into the fastest operational aircraft in history that day. The photos confirmed the destruction of Gaddafi's headquarters, silencing the Libyan leader for years. It was the ultimate demonstration of the Blackbird's philosophy: speed is life. However, the SR-71's dominance wasn't just about speed. It was about the unparalleled quality of its sensors. In the nose, it carried the optical bar camera, a massive device that used 10,500 feet of film per mission. This camera scanned horizon to horizon, capturing a continuous panoramic image of the Earth's surface. The resolution was so high that from 80,000 feet, intelligence analysts could identify the make and model of a car. But the real magic was the technical objective camera, TOC, capable of spotting a golf ball on a putting green. It wasn't just photography. The SR-71 was a flying vacuum cleaner for electronic signals. Its electromagnetic reconnaissance system, EMR, recorded every radar frequency, radio transmission, and microwave pulse it flew over. This data allowed the US to map the entire Soviet air defense network, identifying gaps in the impenetrable Iron Curtain. The Blackbird could fly along the border of the Soviet Union without entering their airspace, yet look 300 miles deep inside. This peripheral reconnaissance infuriated the Kremlin, who would scramble MiG-25s in futile intercept attempts. The MiG-25 Foxbat was built specifically to kill the Blackbird, a brute force engine with wings. It could reach Mach 3 for short bursts, but its engines would literally melt if pushed for too long. Soviet pilots had to launch a head-on attack, a mathematical suicidal maneuver requiring perfect timing. If they turned to chase the SR-71, the Blackbird would simply accelerate and leave the Foxbat in the dust. It was like trying to catch a bullet with a catcher's mitt, one Soviet defector later admitted. The SR-71 crew treated these intercepts as sport, watching the MiGs stall and fall away on their defensive screens. But the operational cost was staggering. Each flight hour cost over $200,000 in today's currency. The fleet required a dedicated support army of maintainers, tankers, and intelligence specialists. For every hour in the air, the Blackbird required 100 hours of maintenance on the ground. By the late 1980s, satellites were becoming cheaper, and the geopolitical landscape was shifting. The Air Force hierarchy, favoring new stealth bombers like the B-2, began to view the SR-71 as a budget-eating dinosaur. They argued that satellites could do the job without risking pilots or causing international incidents. Supporters argued that satellites were predictable. The enemy knew exactly when they would pass overhead and could hide their secrets. The Blackbird was unpredictable. It could be anywhere, anytime, denying the enemy the luxury of cover. Despite the protests of generals and senators, the program was officially terminated in 1989. But the Blackbird wasn't done. It had one final statement to make to the world. On its delivery flight to the Smithsonian in 1990, it smashed 4 transcontinental speed records. It flew from Los Angeles to Washington, D.C. in just 64 minutes and 20 seconds. The average speed was 2,124 miles per hour. The sonic boom shattered windows across the entire continent. When pilot Ed Yielding and RSO Joseph Vida landed at Dulles, they were met by a tearful Kelly Johnson. The plane was still warm, ticking and pinging as it cooled down for the very last time. It had never been shot down, never lost a crew member to enemy fire, and never been outrun. The SR-71 retired as the undefeated champion of the skies, a title it still holds today. But retirement didn't mean extinction. NASA kept 2 Blackbirds flying for high-speed research. They used the aircraft to test new engines, heat shields, and communication systems for future spacecraft. In the mid 90s, Congress, realizing the gap in intelligence capabilities, briefly reactivated the program. 3 Blackbirds were pulled from storage, refurbished at a cost of millions, and returned to service in 1995. It was a short-lived resurrection. The political will wasn't there, and they were permanently retired in 1998. Today, the Blackbird sits in museums, leaking oil on the floor, a silent testament to a lost era of bold engineering. It reminds us of a time when the solution to a problem was simply to go faster and higher than anyone else dared. Modern drones and satellites are efficient, but they lack the visceral, raw power of the J-58 engines. The SR-71 wasn't just a machine. It was the physical embodiment of Cold War paranoia and American ambition. It was designed with slide rules and drafted by hand, yet it outperformed everything designed by supercomputers. No aircraft since has come close to its sustained performance envelope. Rumors persist of a successor, the mythical SR-72, a hypersonic drone capable of Mach 6. But until that aircraft emerges from the shadows, the Blackbird remains the king. Its legacy is written in the record books and in the memories of the men who rode the lightning. "You've never been lost until you've been lost at Mach 3, Brian Schul once said. But they were never truly lost. They were exactly where they needed to be on the edge of the impossible. This is the story of the SR-71 Blackbird, the plane that raced the sun and won. To navigate across the globe without GPS, the Blackbird relied on a piece of technology that seemed like witchcraft. Before satellites surrounded the Earth, the SR-71 used the Astro-Inertial Navigation System, or ANS. Affectionately known as R2D2, this blue box sat behind the pilot, staring up through a quartz window in the fuselage. It was a robotic astronomer, capable of tracking 61 different stars in the middle of the day. While the pilot saw only the black sky, the ANS was triangulating their position with an accuracy of 300 feet. It was so precise that before each flight, the alignment had to be checked against the exact surveying of the hangar floor. This system allowed the Blackbird to fly at Mach 3 with lights out, emitting no electronic signals for the enemy to track. But the most legendary moments inside the cockpit weren't about silence. They were about the radio. Pilot Brian Schul recounts a specific day over Southern California that defined the arrogance of the Blackbird. Training missions were often flown in controlled airspace, monitored by civilian air traffic controllers. The radio chatter was usually mundane Cessnas and commercial liners asking for ground speed checks. A Cessna 172 came on the frequency. Center Cessna 172, request ground speed. The controller replied, "Cessna, I show you at 90 knots. Moments later, a twin Beechcraft piped up, wanting to outdo the little bug smasher. Center, Twin Beech, request ground speed. I show you at 120 knots. The controller droned. Then an F-18 Navy fighter, sensing a competition, keyed the mic with a tone of superiority. Center, Dusty 52, ground speed check. The controller replied, Dusty 52, I show you at 620 knots. Inside the SR-71, Schul and his RSO, Walter Watson, listened to the hierarchy of speed establishing itself. They were screaming across the sky at 80,000 feet, the fastest metal in existence. Watson clicked the mic button. Center, Aspen 20, request ground speed check. The radio went silent for a long beat, the controller pausing to verify the absurd data on his screen. Aspen 20, I show you at 1,942 knots. No one else transmitted on that frequency for the rest of the flight. It wasn't just a number, it was a reminder that the Blackbird existed in a different dimension of physics. But physics always fought back, specifically through the terrifying phenomenon of the unstart. The J-58 engines required the supersonic shockwave to be trapped inside the inlet for efficient combustion. If the computer miscalculated the spike position by a fraction of an inch, the shockwave would be expelled. The result was an instant loss of 80% of the engine's thrust on one side only. At Mach 3, this created a violent yaw, slamming the pilot's helmet against the side of the canopy. The aircraft would try to snap in half. The pilot had seconds to manually restart the intake before structural failure. It feels like driving a car at 100 miles per hour and hitting a brick wall with the left wheels only, one pilot described. To manage this, the crews developed a symbiotic relationship with the machine. They flew by feel, sensing the vibrations of the inlet spikes through the floorboards of the cockpit. The Cold War wasn't just fought over deserts. It was contested over the icy waters of the Baltic Sea. The Baltic Express was a routine loop flying fast and low to trigger the Soviet air defenses in Poland and East Germany. It was here that the SR-71 met its only true challenger, the Swedish JA-37 Viggen. While the Soviets chased from behind, the Swedes developed a tactic to meet the Blackbird head-on. Utilizing ground radar, Viggen pilots would climb vertically, executing a perfect ballistic arc to get a radar lock. It was the only aircraft to ever successfully achieve a firing solution on the SR-71. They never fired, of course. They were neutrals, merely proving it could be done. The SR-71 pilots respected the Viggens, often dipping their wings in a supersonic salute as they flashed by. These cat-and-mouse games required absolute precision. A 1-degree navigation error meant violating sovereign airspace. And then there was the Dipsy-Doodle, a maneuver used to defeat the sophisticated Soviet SA-5 missiles. The SA-5 was designed to predict the Blackbird's trajectory and detonate a nuclear warhead in its path. To confuse the guidance computer, the SR-71 would execute a gentle, continuous turn at Mach 3. The missile's computer, assuming a straight-line target, would constantly recalculate until it ran out of energy. Pilots were effectively outsmarting a microchip with geometry and raw kinetic energy. But the most dangerous part of the mission wasn't the missiles. It was the tanker rendezvous. Slowing down from Mach 3 to 300 knots to refuel was like parking a Ferrari on a moving freight train. The Blackbird had to fly at a high angle of attack just to stay airborne at tanker speeds. Flying the SR-71 behind a tanker was a delicate dance of aerodynamics and patience, often done in silence. The tanker crews, flying the KC-135Q, were the unsung heroes, carrying the specialized JP-7 fuel. They often pushed their own aircraft into the coffin corner of their flight envelope to give the Blackbird a chance. Refueling took place at 26,000 feet, but the SR-71 burned fuel so fast it often needed to top up multiple times. Once the boom disconnected, the pilot would light the afterburners, and the Blackbird would leave the tanker as if it were standing still. The transition back to Mach 3 was a physical sensation, the aircraft stretching and groaning as it heated up again. Kelly Johnson's design philosophy was validated every time the aircraft survived these thermal cycles. He had designed the hydraulic fluid to function at temperatures that would boil water. The electrical wiring was gold-plated because copper would oxidize and fail at sustained high temperatures. Even the pilot's ejection seat was a marvel, designed to stabilize a human body entering a Mach 3 airstream. In the event of a bailout, the suit would inflate, and a drogue chute would prevent the pilot from tumbling into a redout. Miraculously, despite several accidents during testing, no SR-71 pilot was ever lost in the operational aircraft. One famous incident involved pilot Bill Weaver, whose Blackbird disintegrated around him at Mach 3.18. The aircraft suffered an unstart that snapped the fuselage, throwing Weaver into the stratosphere. He fell 78,000 feet, unconscious, his pressure suit acting as a life raft in the thin air. He woke up floating in the Pacific Ocean, alive, a testament to the engineering of his survival gear. But the machine was more than just a survivor. It was a diplomat of raw power. During the 1976 Montreal Olympics, the US wanted to show off, but the Blackbird was still highly classified. Instead, they used it to intimidate, flying sonic booms over key geopolitical summits to remind leaders of US reach. The sonic boom was its signature, a double crack ba-boom caused by the nose and tail shockwaves. On cross-country flights, the Blackbird would drag this sonic carpet across entire states, rattling windows from coast to coast. It was the sound of freedom to some, and the sound of impending doom to others. By the 1990s, the world had changed. The Soviet Union had collapsed, and the threat environment shifted. The need for overflight reconnaissance diminished as enemies moved underground or into urban centers. Satellites could now provide real-time data, and drones like the Predator were cheaper to operate. But none of them had the psychological impact of the Blackbird. A satellite is a silent observer. An SR-71 is a screaming statement of intent. When the Blackbird appeared on radar, enemy air defense networks lit up, revealing their locations. This provocation capability was something a passive satellite could never replicate. The SR-71 forced the enemy to react, and in reacting, they revealed their secrets. Today, the airframes rest in museums like the Smithsonian and the Air Force Armament Museum. Standing under the fuselage, you can see the leaking oil pans on the floor, the blood of the Blackbird. It feels dormant, not dead, as if a single shot of TEB could wake it up. The titanium skin is still blue, black, scorched by the friction of 1,000 missions. Touching it, You are touching metal that has been hotter than a pizza oven while on the edge of space. It remains the only aircraft in history to be retired without a successor ready to take its place. The void it left in aviation history has never been filled. Every modern fighter jet, from the F-22 to the F-35, owes a debt to the stealth research pioneered on the SR-71. The chines, the canted tails, the radar-absorbent materials, it all started at Skunk Works in the 60s. Kelly Johnson passed away in 1990, just as his greatest creation was making its final flights. He died knowing that he had built the impossible, a machine that outlived the Cold War itself. The men who flew it are now old, their numbers dwindling, but their stories remain sharp. They speak of the view from 85,000 feet, where the sky is black and the curvature of the earth is undeniable. They speak of the silence of the cockpit, broken only by the rhythmic breathing of the pressure suit. And they speak of the speed, the godlike feeling of outrunning the sun. In the end, the SR-71 wasn't just a weapon, it was a peak of human achievement. It proved that with enough titanium and enough will, humanity could touch the edge of the cosmos. We may never see its like again. Faster than a speeding bullet. The SR-71 Blackbird. Addendum. The Blackbird family and the forgotten variants. The SR-71 was the celebrity, but it was born from a darker, more secretive sibling, the CIA's A-12 Oxcart. Flown by drivers, not pilots, the A-12 was a single-seat aircraft, lighter and faster than the SR-71. It was designed for one purpose: to replace the U-2 before the Blackbird was even a concept. The A-12 flew missions over North Vietnam and North Korea during Operation Black Shield, unpainted and marked with fake serial numbers. But the most dangerous variant was the M-21, a mothership designed to launch a Mach 3 drone, the D-21. The D-21 was a ramjet-powered autonomous spy craft, mounted on the back of the M-21 like a parasitic twin. Launching a drone at Mach 3 was a feat of insanity. The shockwaves between the two aircraft created a turbulent kill zone. On the 30th of July 1966, disaster struck. The drone failed to clear the mothership's shockwave. It slammed into the tail of the M-21, pitching the massive aircraft up and snapping it in half at Mach 3. Pilot Bill Park and Launch Control Officer Ray Torek ejected into the Pacific Ocean. Torek drowned when his pressure suit filled with water, a tragedy that ended the M-21 program instantly. While the A-12 and M-21 were spies, the YF-12 was a killer. This was the Interceptor variant, armed with 3 massive AIM-4-7 Falcon missiles in internal bays. It was designed to hunt Soviet nuclear bombers before they could reach the American coast. The YF-12 had a fire control radar so powerful it could guide a missile to a target 100 miles away. In tests, it successfully intercepted a B-47 bomber drone flying at 500 feet, while the YF-12 was at 74,000 feet. It proved that Mach 3 interception was possible, but the Vietnam War drained the budget, and the program was cancelled. The heart of all these beasts was the starting mechanism, a piece of ground equipment known as the AG-330 start cart. To wake the J-58 engines, you couldn't just push a button, you needed brute mechanical force. The start cart utilized 2 Buick Wildcat 401 cubic inch V8 engines, similar to those in American muscle cars. These V8s would scream at redline to spin a vertical shaft connected to the J-58, physically cranking it up to speed. The sound of 2 unsilenced V8s roaring beneath the hissing jet was the deafening overture to every mission. Once the J-58 caught, the start cart was disengaged, and the green flash of TEB would signal the beast was alive. The logistics of fuel were equally complex. JP-7 was so unique it required a dedicated tanker fleet, the KC-135Q. These tankers had separated plumbing systems to ensure the JP-7 never mixed with the tanker's own fuel. If an SR-71 diverted to a base without JP-7, it was grounded until a tanker could fly in the fuel. One pilot recalled landing in England and having to use start carts borrowed from a drag racing team because the base equipment failed. The SR-71 also had a sophisticated electronic defense system, the Gold Box DEF system, which jammed enemy radar. It didn't just blanket jam, it used range gate stealers to trick the missile into thinking the plane was somewhere else. The missile would fly towards a ghost signal, detonating harmlessly in empty air miles from the jet. This electronic wizardry was just as important as the titanium skin in keeping the crew safe. The pilots themselves wore the David Clark S-1030 suit, which was later adapted for the space shuttle crews. The suit was heavy, hot, and smelled of rubber and sweat, a claustrophobic second skin. Scratching an itch was impossible. You simply had to endure it for 10 hours. To drink, they used a straw inserted through a port. To eat, they squeezed tube food like peaches and heavy syrup. The tube food became a rite of passage, a culinary disaster that every Habu had to tolerate. Despite the hardships, the morale was incredibly high. They knew they were the only humans at that altitude. They developed a tradition of Habu patches, unofficial mission patches that mocked the secrecy of their work. One famous patch featured a mushroom cloud with the text, SR-71, you've never been lost until you've been lost at Mach 3. The operational ceiling was officially 85,000 feet, but rumors persist of flights touching 100,000 feet. At that altitude, the sky is black, even at noon, and you can see the curve of the Earth spanning California to Texas. It is a view reserved for astronauts and Blackbird pilots, a lonely, silent frontier. The Blackbird also served as a testbed for NASA's LASRI experiment, Linear Aerospike, SR-71 experiment. A massive canoe structure was mounted on the back of the jet to test engines for the X-33 Venture Star. It proved that the SR-71 was robust enough to carry piggyback payloads even in its twilight years. The engineering margins Kelly Johnson built in were so high that the airframes were actually getting stronger with age. The heat annealing process of each flight effectively hardened the titanium fuselage over decades. If not for the budget cuts, the Blackbirds could technically still be flying today. They were killed not by enemy fire or metal fatigue, but by the stroke of a pen in Washington. The SR-71 represents a specific moment in human history, the apex of the analog age. It was designed before computational fluid dynamics, CFD, existed to simulate airflow. Kelly Johnson and his team calculated the thermal loads using slide rules and log tables. They drafted the blueprints by hand on thousands of sheets of mylar, smelling of graphite and eraser dust. Today, a supercomputer can design a more efficient wing in seconds, but it cannot replicate the intuition of the Skunk Works. The Blackbird is a testament to gut-feeling engineering, knowing when the math is wrong because the metal feels right. This is why the tooling was destroyed in accordance with McNamara's orders in the late 60s. The massive jigs and molds used to shape the titanium were cut up and sold as scrap to prevent anyone else from building one. We literally destroyed the capacity to reproduce this machine. It is a lost art, like the forging of Damascus steel. If you wanted to build an SR-71 today, you couldn't. The supply chain, the skills, and the tooling are extinct. But the dream of speed did not die with the Blackbird. It just went deeper into the shadows. For decades, aviation enthusiasts have whispered about Aurora, a mythical hypersonic successor. In 2013, Lockheed Martin finally hinted at the existence of the SR-72, or son of Blackbird. The projected specs are terrifying. Mach 6, hypersonic cruise, twice the speed of the original. Unlike the SR-71, the SR-72 would be unmanned, removing the biological weak link from the cockpit. It would use a turbine-based combined cycle engine, merging a jet engine with a scramjet. But until that aircraft rolls out of a hangar in Palmdale, it remains a ghost story. Real power is not what you promise to build. Real power is what you have already flown. The SR-71 is not a promise. It is 32 airframes of proven, tangible dominance. It flew the timeline of the Cold War, from the Cuban Missile Crisis era to the fall of the Berlin Wall. It watched empires rise and collapse through the quartz glass of its cameras. It outran over 4,000 missiles, leaving frustrated radar operators cursing in Russian, Arabic, and Vietnamese. It turned the entire planet into a neighborhood, crossing continents between breakfast and lunch. Standing next to it in a museum today, the silence is heavy. It looks like a predator resting with one eye open, black paint absorbing the gallery lights. The oil drip pans underneath are the only sign that it is still fighting gravity. For the pilots, the Habus, it was the defining relationship of their lives. They didn't just fly it, they wore it, they breathed with it, and they trusted it with their lives. Major Brian Schul summed it up best. There were no simulators for the soul. The sensation of seeing 2 sunsets in one day, of seeing the stars at noon, changed them forever. We live in an era of slow stealth, of loitering drones, and electronic warfare. We value persistence over speed, and invisibility over kinetic energy. But there is a primal part of the human spirit that misses the brute force of the Blackbird. We miss the thunder of the J-58S cracking the sky open, We miss the audacity of a plane that didn't need to hide because nothing could catch it. The SR-71 Blackbird was the ultimate expression of American aerospace arrogance. It was dangerous, expensive, leaking, and temperamental. It was also perfect. As long as history is written, it will record that for 3 decades, mankind flew at Mach 3. And we did it in a titanium dart built by a guy named Kelly.